Hey everybody, today we are going to be talking about which is the best fit for a certain set of data. You know, we've been talking heavily the difference between linear functions and exponential functions. Well, now what's going to happen today is I'm going to give you some data, and I want you to tell me, okay, what would be the best fit? Would it be a linear fit or would it be an exponential fit? Okay, so let's just sort of review the graphs of each one of these real quickly. Okay, so if I asked you to draw me something that was linear, okay, what would you draw for me? Okay, and hopefully you responded by saying, duh, a straight line. Okay, so you can either have one that goes like this or this. Okay. Okay, you have the two special cases as well, but for right now, we're only going to focus on these two. But yeah, and in the word linear is the word line. That should be the dead giveaway. Okay? Now, this is a little bit newer, but if I asked you to draw me something that was exponential, okay, what would your graph look like then? Okay? And hopefully, if you remembered, if not, that's okay, that's why I'm here. You responded by saying, oh, some sort of J curve. Okay, so we've got two of them. You've got one that does something like this, okay, or the other way. And they have those two fancy names. The one that goes up this way, we call that growth, and the one that goes down like this, we call that decay. All right, so that is the difference between the graphs, and that's going to be crucial for when we actually start talking about how do you graph these sorts of things. Okay, and how can I tell based off the graph, should I use linear or exponential? All right, so next thing I want to talk about is a nasty word but easy concept. So a definition here, and it's called the correlation coefficient. Okay. All this is, it is a number that determines if our fit is the best fit. Okay. What that means is that this is a certain number, guys, that will tell me, okay, by looking at the number, I know that a linear fit is going to be the best fit. Or that number, okay, that number is a dead giveaway that this is going to be an exponential fit. Okay, so a couple more things you need to know about this. We denote the correlation coefficient with R squared. So again, this stands for correlation coefficient. And the goal for your R squared value, it needs to be as close to 1 as you can get it. As close to 1. Okay? Will it ever go over 1? No. Okay, the correlation coefficient is a number between 0 and 1. Now, the closer that your correlation coefficient is to 1, the better your fit is going to be. Okay, and we're going to look at that more when we actually use some technology. Okay, we're going to be using our calculators to do this. All right, so let's just go right into it. Let's look at some examples and make sure that you use your calculators because we're going to need them. All right.